All right, guys, good morning. This is Hoffbauer's attempt to make a quick video on box and whisker plots and doing the 5-number summary on your calculator. So this aligns with worksheet 19, and then it's going to lead into section 11.1 descriptive stats, which we'll do as a separate video. If you have a copy of the worksheet, that's great. Otherwise, I will make sure we attach a PDF of it in your post that includes this video. All right, the book assumes that we did lesson 0.8, which was on finding one variable stats and using either the mean or median to describe the center of the data, and then to describe the spread or variability using either the standard deviation or 5-number summary. So we are going to quickly go through how to do all that. So what you will need to know how to do is find the mean, median, mode, and the standard deviation on your calculator. You will not have to know the formulas by heart. And you will also need to know what the 5-number summary is. Okay, so this is off worksheet 9. All the data we're going to use for our examples are right here in this little box. Mrs. Williams' algebra class took a test, and here's their scores. If you glance through them, we're going to talk about outliers. I'm thinking this person didn't study very hard and maybe they're going to be an outlier. All right. So to enter this into list 1, we're going to go stat, enter, and then we're going to put all of the items into list 1. You're already really good at this. So actually I sorted mine already because this is my 3rd attempt on this video. So just put them in the order they're given. Okay. 80, 80, 100, 90, 80, 70, 75, 30, 60, 80, 85. Pause the video if you need to. All right. Then once you have the data in, we are going to go stat, right arrow, and the very first choice here is one variable stats, and that's what we want. Going to hit enter. We do not want a frequency list, so make sure that's blank if this option comes up on your calculator. Then calculate. All right, real important here, if you're not in province stats or AP stats, this is the mean. This X bar, it's called, is the mean. Okay, so the mean or the average, where they added them up and divided by how many tests were given, is 75.45. This is the sum of all the test scores. This is the sum of them squared, which is used to find the variance. This is the standard deviation, which indicates how spread out the data was, and we'll talk more about that. And population standard deviation. Okay, for right now, what I want to concentrate on is what's on the worksheet, and it says N is 11, meaning there were 11 items that we typed in. That's always real important because I always double check that I didn't mess up and type something wrong. And then the next thing on our list is the minimum, Q1. And if you keep scrolling down, you'll get what's called the whole 5-number summary. These last 5 things here, the minimum, the first quartile, which is where 1/4 of the data falls below and 3/4 falls above, 70. And then the median is the exact middle when they're put in order, or the average of the 2 middle numbers if there's an even number of items. And Q3 is the 3rd quartile or the 75th percentile mark, where 75% of the data is below this, 25% is above, and the max. So this is called the 5-number summary. So real quick, filling that in on the worksheet. Let me see, what do I want to do? I want to go to this page and put this over here. Okay, so the value of N was 11. The mean of the test scores, that was that X bar at the top. I believe it was 75.45. The mode, okay, that's the most often given score or occurring score in this list, most often occurring number. And most of the time, you can just pick it out, but I did want to show you real quick that it is possible to go to your list, stat, and then pick either sort ascending or descending, and then put in the list number that you put them in. So I did list 1, and then it'll just say done. But now when I go to my list, they are in order from smallest to greatest, and I can quickly tell that 80 was the most often given score. Okay. So that's the mode. The median, oops, that's supposed to be 80. I don't know what I'm doing. The median over here was also 80, the most often occurring. I'm sorry, the median is the middle, okay? So that means half above and half below. Find the low, extreme, or minimum test score. That was 30. The upper, extreme, or maximum test score was 100. And remember, all of this was under one variable stats. And we did have to arrow down to find that 5-number summary. So the range of scores is simply max minus min, or 100 minus 30. There was 70-point difference between the top score and the bottom score. All right. The interquartile range is the difference between Q3 and Q1. So let me one more time put this on the screen for us. Okay. So this is the definition of the interquartile range. So it's 85 minus 70 or 15. The interquartile range is used to decide whether there's outliers. The definition of an outlier is if it's more than 1.5 times the interquartile range away from the median. That's complicated. There's a way the calculator will do this for you. I'm going to show you real fast, but it says find the smallest possible value while not being an outlier. So that's the median minus 1.5 times that IQR, or interquartile range, which is this number. So our first quartile was 70, no, the median, I'm sorry, was 80 minus 1.5 times 15, which did it once and thought there it is. It's 57.5. So anything below 57.5 is an outlier. And then find the maximum possible while not being an outlier. That is the same 80 plus 1.5 times the interquartile range, which I believe turns out to be 102.5, and we don't have anything that high. So which score is above or an outlier was that 30, because it's clearly below this number. Okay. What percent of students scored above 85? Well, Q3 was 85. So that means 25%. Quartile 3 means the 75th percentile. 25% were above 85. How many students scored below 85? That would be 75% then. All right, now this is not what I thought was on the next page. Let me go back and scroll down. Here we go. Okay, so what we need to do now is to draw the box and whisker plot down here. So I'm going to go to my calculator just to show you how to do this. It's second y equals, turn a stat plot on. My numbers are in list 1, but what I want to choose this time is the one that kind of looks like a robot head down here. I'm going to choose the first one that has the 2 dots behind it, because those dots are the outliers, and it will show any outliers as a dot rather than as part of a long whisker. The rule is a whisker can only be 1.5 times as wide as the box. If it's longer than that, then there is an outlier. All right, if I hit enter there on that first one, it will only bring up one list, because I'm only using one set of data points, not comparing 2 and not using a frequency list. So make sure it says the right list number, and then that it's turned on. And then to see it, I'm going to do a zoom stat real quick, and it should show up. Okay. Remember we discussed that 30 was an outlier. If I hit trace, there's our median of 80. 70 is Q1. The min, is 30, but because it was an outlier, it connected our box and whisker plot only to the last data point before 30. And then if I go back up here, there's Q3 and the max. So again, that was second y equals stat plot to turn it on, and we chose the one with outlier. So I'm going to go through that, doing that by hand one more time. So what I really want is this screen. So what you're going to draw on your box and whisker plot is you're going to put, you're going to put the median on, and then Q1 and Q3. You're supposed to be lining these up against this number line, and that's your box. Okay, and then the whiskers go out to the max and the min. The max was at 100, and the min would have been down here at 30. But remember, this was an outlier, so on paper we usually put that as a star. And then we go to the next highest data point. If I wasn't sure, I would go stat, enter, look at my list, and go look. If I lop off 30, the next highest one is 60. So I'm only going to connect my whisker out to 60. Okay, just real quick again. The box always contains the middle 50% of the data. Each half of the box contains 25% of the data. Now, this whisker is longer. That doesn't mean there's more data out here. It's still 25% of the students scored up here. What it means is their scores were more spread out, okay, as compared to this 25% of the data. And the same with the box. This is also 25%, okay? It actually includes that data point, so it's a little confusing, but the this half of the box is longer. This is a difference of 10. That means this 25% of the data was more spread out. There were 25% of the students who scored exactly between 80 and 85. All right, so that's a box and whisker plot explained very quickly. Other thing I want to show you real fast is just a couple examples off the back. So it says, in Bramley's shop, there are 6 types of phone cases for iPhone 8. The price of each is shown below. Calculate the mean and standard deviation of these prices. Okay, we are going to use this. It says it has a mean of this and a standard deviation of 2.3. So we should be able to tell what they... Oh, no, that's a different set. Okay, I got it. Sorry. I'm going to just go up and clear my list and put these in. 19, 25, 17, 32, 20, and 22. Okay, and then it's stat, right arrow, it's the very first choice, enter. And they want the mean and the standard deviation, which are both on this screen. So the mean for these iPhone 8s is 22.5, and the standard deviation, this is the population standard deviation, no, sample standard deviation and population, I believe. I'm not really sure which one we want you to use. I know we specified on the quiz when we gave a quiz. I am going to go with this first one. All right. In the same shop, the prices of the Galaxy phone cases has a mean of 22.5 and a standard deviation of 2.3. So the means are equal, but the standard deviation, which I'm just going to abbreviate like this so you know what I'm talking about, is 5.4 for the iPhones and 2.3 for the Galaxy cases. So does anybody know what that means? It means that the iPhone cases have a bigger, their standard deviation means they're spread out more, okay? So you can, it says compare the two sets of data making particular references to the spread of the prices. So what they want us to write here, and I'm actually going to type because it'll look so much nicer. All right. While the two types of phone cases have the same mean or average price, the iPhone cases have a much larger standard deviation, indicating the prices are more spread out. Okay, so that's the idea between a standard deviation being larger is just that they're more spread out. The data is more spread out. Okay. Example 2 says the average or mean cost of 10 types of headphones is 15. So we had 10 different kinds of headphones and we averaged them. We took and divided by 10, so there was the total of all of them, and we got an average of $15. The average of 8 different headphones is $88. So maybe we went to a different store or whatever, but we had the total and there was 8 of them and we ended up for $88. So what is the mean cost for all 18 sets of headphones? Okay, so we got to figure out a way to average them as though they were one giant set. Well, the easy way to think of this is just if there were 10 of these and they averaged out at $15, their total had to be 10 times 15 or $150. These, there were 8 of them and they averaged out to $88 a piece. So their total is 8 times 88. Yep, Hofbauer's going to need a calculator again. So $704 if you were to buy all of those. So if we want to average them together, there's 150 and 704, or a total of $854 worth of headphones. And that was a total of 18 pairs of headphones. So 854 divided by 18 is 47.4. So the average price over all 18 of them is about 47. I think it was 44 or something. All right. So this video got longer than I wanted it to be, but that is a quick overview of the kind of problems that you are to do on the bottom of 9B and how to look at a box and whisker plot. Thanks, guys. Stay well.